Welcome back, everyone. And this is kind of a continuation of the previous video where we did pure transforms. But the main focus of, to me, the last video was creating a new function called transform node. Because I needed that because the next thing I really want to do is to revamp my armature system. The armature system that we've been developing has been very kind of black boxish. Maybe not black box like, more like it was self-contained. All the objects and everything to create the bones and the hierarchy and everything were all contained within the armature system only. That's it. It didn't do anything else. And I want to be able to do certain things with bones, like add physics to it, add movement, and just add scripts to bones in general, or do sockets. So this way we can have objects. Like if I have a hand and I'm moving the hand, I want to have like a sword move with the hand. So I need to create sockets. Now, here's the thing. For the way I built the armature system, having everything kind of self-contained, that means I would have to build all these systems into the armature system, which is kind of silly. And that's when I came to realize how Unity and Unreal does it. And the way they do it, I never made sense to me. Even Blender, all bones are global objects. In our instance, they're entities. They're just game objects. I think in Unity, every bone is really a game object. And like any other game object, it has a parent-child relationship, so you can add children underneath it. You can add scripts to it, and you can add whatever you want to it. It's a game object. And that's when I came to that realization. To get all that functionality, I need to turn all my armature bones into entities. They need to become game objects. So that's what this video is about. It's transitioning away from that self-containment and actually bringing armature into the ECS framework. So this is how I'm building an armature system using ECS. So like I said in the previous video, I created a new way of doing hierarchy. It was just a revamped way of doing hierarchy, and I'm using transforms instead of doing a lot of matrices when we're doing parent-child relationships. So one of the things I decided to apply when I'm rebuilding it is adding scale, because before we're using dual quaternions, and dual quaternions don't hold scale. So they only hold rotation and position. So we're going to add an extra value to all our bones that allows us to scale, and not scale at a single value, but scale at all three axes. So if you want to scale by X, Y, or Z, or any combination of the three, you can. And here's an example. I am scaling the final element. The final bone is being scaled dynamically. And as the bone is being scaled, that value is going to be applied to our skin, our mesh, and the mesh itself is being scaled. And the scaling is also weighted by bone. So you can see that the scaling from the top bone to the middle bone is scaled. So this way it scales evenly, it scales correctly. So this armature system has been, like I said, being upgraded with new features that I think a year ago someone was doing something with armatures with 3DS, and they wanted to do some funky scaling things with their bones, but they couldn't because 3DS only supports one scale value. Just you say a scale of 2 and it scales all three axes. So in this system, all three axes are different. So you can scale by X. Like in this instance, I'm only scaling by X and Z, not by Y. I'm leaving Y alone. If I scale by Y, then it'll just start going up further, which maybe I'll see if I can add to it. So if I want to make bones into entities, bones is going to be a component. And before, all our joints, and like before I was calling it joints, now I'm calling it bones, because now we have extra values, because we have a rotation, but then we kind of have a length. So this way we know how long the distance is for that specific joint. So this way we have a reference of what vertices it has influence on. So when we're from that video about how to do auto weights by using bones. So since I had a hierarchy and everything else built internally, I decided to rebuild it again in using transform nodes. So this way, bones component doesn't have to handle transform data. Doesn't have to handle transform hierarchy data either. All it has to handle is bones. And like I said, those are features that were built into the system internally. And now I took that away, and the armature system only handles bone data, just bone data. It doesn't handle parenting and transforms anymore. Like they used to handle that internally, its own copy of it. Not anymore. Now everything uses the entity framework for it. So if we're going to, and if you go into our fungi mod folder, before we have a folder called armature. Now there's a new folder. If you look at the GitHub, it's full armature E. So this is the new system. This is the armature entity framework. This one uses our entities for bones. And let's see, our armature system. So instead of a joint object, now we have a bone component. And the bone component has a lot of information we need for a specific bone. We need to know the order of what it is. Because if I bring in bone data or joint data from like Blender's things, they're not ordered from 0 to 1. They're like kind of thrown all over the place. So I need to know the order. So this is when I sort. I need to be able to sort them in the proper order to upload them to the shader. So that's kind of important. Like the way I build everything in the right order programmatically, but when you're using external tools, it's not so much, because you can delete a bone in the middle, add a bone, and all the numbers get mixed around. So yeah. So we have the length of the bone. We have the initial. So when we remember this, everything we've done so far with armatures is still in effect. The only I think before I used to have like bind scale and stuff like that. Now I'm saving I'm just calling it init. This is when we create our bind pose. I'm going to save the values that I used for that to create that bind pose. So this way, if I ever want to reset my transform, like let's say I want to reset, like let's say I transform the armature like crazy, and it's moving, it's doing poses, but I want to reset it back to its original pose. I can use these values to reset the entire armature, or at least I can reset this bone back to its original bind pose position. So everything's back to being its T pose or its whatever it was modeled at, the pose that was modeled at, the default pose. Again, we still have our dual contortion bind pose and offset pose. Before we used to have world, we had I think we had maybe 2 or 3 or 4 dual contortions to deal with. Now we're just down to 2. Those are things I was experimenting with. I got rid of. I probably should just delete them now. So that's our new bone component. So this one gets attached to an entity that has both a transform and a transform node. So bone is an important aspect of it. Armature, I don't think changes too much. Now we have there's small changes here and there. I changed naming. Like I stopped calling them joints and I'm calling them bones again. Like I said, we're going to deal with scale. So before we just flat offset, now we have flat scale as well. The init doesn't do much of anything anymore. I think it used to do something. It doesn't need to do anything anymore. Finalize does the same thing. It sorts our bones, creates our bind pose, and then sets up basically our binary buffer to hold all our offset data and scale data. I have a warning here. Even though this is a float 33, even though the scale is a float vector 3, it has to be 4. Because UBOs, when you're dealing with arrays, have to be at 16 bytes. So I need to create the scale as if it's a vect4. So in case you say, why is that a 4? It's not a bug. It's because of UBOs. I need it. So this way, when I create it, I can just dump that straight into a UBO and not worry about it. So that's only a little issue I had to deal with to fix. This actually caused me a lot of problems. So I didn't think it was going to give me a problem. All my scaling was screwed up until I realized that this buffer data needs to be at 4 floats, not 3 per scale. Like I said, a lot of code stays the same, but a lot of it is just slightly different. Like let's say now when we create a new bone, we create a new entity, and we give it a name, and we give it the list of entity components we need. And I think I have at the very, very top. It's just an array. So like I said, it needs so now for a bone entity to exist, these are the components it needs. These are the main ingredients of making a bone work. And then we just create the child. We just give it the order, its length. If we don't give it an order, we just give it the order that's created, and its length would be, it automatically add position based on the parent's length. So there you go. Very simple. Sort bones. It's just sorting. There's actually a bug here, to be honest. I fixed it yesterday, but I'm like 2 videos ahead already, program-wise. So in the future, just remember this code is actually wrong. It created a big bug for me. The bug is that these are entities. So what I need to do, what I did was I did basically like a equals a dot com level. That's part of transform node, and then I did bb equals b.com.transform node. Then I can then these will then work out, because I did not realize I was passing in entities. So this is really how I fixed it. So same idea for this one. This is order, so this is actually bones. So just bone, bone. Still lightning today. So oops, I saw an error here. You probably were watching the video, me typing like, Pedro, you made an error. You made an error. B, and there you go. And I'm an anal for that kind of. So yeah, like I said, I fixed it yesterday, but I did not fix this in the GitHub for this lesson. So that should fix sorting. So sorting should work perfectly. Like you wouldn't even notice it when you're dealing with small, like 3 or 5. I think I started creating chains of like 12 bones, and everything just got screwy after that. Then that's when I noticed that there's a bug here. Hopefully I didn't break it. I guess we'll find. You know what? I can test very easily if I broke it or not. Refresh. Nope. See, I fixed sorting. Sorting still works. Okay. So that's sorting. Buy and pose still follows the same, but the code is a lot more simplified. Like, since I don't have to deal with parenting and everything else, no big deal. So before you run this code, you just have to run the parenting code before it. So this way, the transform node has been updated, and you're done. You're good. So this way, the armature system doesn't have to deal with all that crap anymore. So yeah, so the bind post becomes more simplified. So it's more simplified code, and this is how to update the offsets. It's been simplified. Everything we learned in the previous video is all there, except we're not dealing with parent transforms anymore, or the hierarchy anymore. This doesn't handle it. Transform node handles the hierarchy, and then when that's been done, taken care of, bones then runs afterwards as a system. So if we're building systems, transform node runs, then bones runs a second. So this way it takes all the final values and then creates a dual quaternions out of it. And flattened data is practically the same thing. The only difference is this. So, and that's it. And again, I got to put that fourth component as 0 because it's a UBO requirement for using arrays. I'm sure there's a video about UBOs, and when we were creating UBOs, I always mention it. So that's armature. So like I said, the armature system has been slimmed down quite a bit. Armature preview, it's only small changes to armature preview. It really just, now I have the scale location to deal with. I have certain things have been moved around, but overall it's the same idea. I think I used to store these values somewhere else. Now armature preview, I think it's a component. I made it into a component. Yes, it's a component. Before it was just an object. So a lot of things have been converted into components to make things life easier. Like I said, there's not really too much that's changed. This still applies to all the armature videos I've done in the past. Use stick, use diamond. These are just different things. Use circle line, whatever. The VO changed. Like I said, we need to add scale. So we're dealing with scaling. So we're previewing our things, so we add scale to it. Flatten data, same thing. Update buffer, again, it's just extra lines of code just to deal with scaling. And that's it. Armature preview is the same. Like I said, for the most part, just adding scaling to it and just tweaking things here and there, and probably taking things out that no longer need to be there because they're being dealt by transform node. Armature system, very bare bones. It just updates the offset and flattens the data. And if this component exists, it does the same thing for armature preview. And armature system should run after, I guess, transform nodes have been updated. Don't need that. And that's our UBO. We're creating a new UBO. So before I used to pass it in through the shader. Now I'm just passing it through the UBO. Very important reason why I want to do UBO for this. Other than the fact that, you know, it's just you do upload it once and I have to deal with shaders. It's easier to do it this way. I don't even remember where I do the uploading to. I think I do the uploading somewhere. But the real reason, one of the reasons why is that because I created a model recently, and it's two pieces. I have like these spheres that act as joints, and then I have like this armor. So they're two different meshes, and they're going to be rendered differently for each one. So like the sphere pieces, I might want to glow and do some weird funky things to it, and the armor pieces, I want to leave them alone. So like I said, I want to do two different renders, and I might want to do other renders. Like I'll maybe do like an outline or something. So to do that, I need to be able to render the entire armature multiple times. So the idea is of constantly uploading for every shader. I'm going to upload it once to a UBO and then have every shader use that UBO. So this way, I upload the data once, and then I can have all the shaders that I want to apply to that armature just use that data once. So it's very efficient. It makes things easier to deal with. So all I have to do is make sure all the shaders that related to an armature are kind of batched together. So this way I just say, okay, upload it once, run all these shaders on this armature, and call it a day. And that's that. So that's reason why you should really use our UBOs when you're dealing with armature data, especially if you're going to do a lot of rendering on it. It's like especially like how we're going to do it in the future. We're going to do a lot more, some fun stuff, hopefully in the future once I get my IK rig system working really well. So that's it. So let's look at the preview one, the preview shader. So the shader, like I said, we just press in scale, renamed a couple things. In this instance, I don't need the UBO because I'm not doing skinning. So I pass everything in as buffer object from our preview. So in case you don't get it, go to preview. This is where we're creating our VAO. So this is where all the data is coming from for our preview. So it's a VAO, not a VBO. So it's just a vector buffer object. This is the regular where all our stuff comes from. So this is our quintorians. This is the length of our bone, and this is the scale. And when it comes to it, you get the position, you fix it up by adding the length, because the length is dynamic. And just like in the previous video, I said all you have to do is just scale it, and rotate it, and then add to it. And mind you, this right here, I'm using the pure transform method from the previous video. I'm not using model matrix. So like I said, this gives me some control over the scale a little bit. Well, not really. I don't have any control. Doesn't really matter because I'm just changing the position and I just do it. I can actually just put the model matrix in here, but like I was experimenting. I was actually trying to get this to work. Pure transform was trying to get it to work with armatures, and I couldn't get it working with skinning. I can get it working with previews, but I can't work with skinning. But yeah, this is the skinning example. You don't need to do contouring and whatnot, or you don't have to deal with contouring this way. So yeah. And in skinning, I still call things joints, but I can probably name them to bones at some point. Here is my armature. Everything's set for 60. If you need more data for your armature, if you have like more bones and stuff, you can change the scale to 60, and definitely don't forget to fix the UBO. And you might have to fix a couple other things. But the UBO where I create, I think I set it for 60. Make sure you change that value. This probably should be a global value somewhere, but for right now it's kind of hard-coded in like 2 different spots. And I think it's probably the armature system where we create the flat. Oh no, I just created based on length. So you don't have to worry about it here. So it's just the UBO and this shader you need to fix if you want to bring in more information. Because everything else is dynamic. It just whatever bones you have, it just creates it. So some changes here. Originally, I was doing this. I was doing everything dynamically. So if I pass in like 2 joints, I run the code this way, and I have a loop. I decided to get away from that because if statements and loops are supposedly supposed to be very slow for shaders. Like you won't notice it really, but unless you have like tons of other things happening, it might slow you down a little bit. So I decided to break things down a bit. So I have my dual quaternion transform function. So this handles dual quaternion transformation. Very simple. That's all it does. Then I have my dual quaternion joint transform 2, which bad naming, but what this does is it handles the weight and the calculations for 2 bones. So ideally, I would have to create 3 functions. 1 for 2 bones, 1 for 3 bones, 1 for 4 bones. And then have the shader use that specific one for it. I can create something called 4 and just fix all this math up to handle 4. So this way there's no if statements, there's no loops. All the weighting is done, so it's if I want to add more weights to it, like if I wanted to say do 4, it's just X, Y, Z, W, and then essentially do the exact same thing for these things to add more weights to it. So to add 4. So ideally I could just make a 4 function and just do it, but I'll probably want to have maybe like I said 3 functions to keep efficiency. Like if I'm building a system that only has 2 bone weights per vertex, this has less math. If I know if I'm going to use 3 bones, let me get a 3-bone function just working. So I'm like I said, I'm taking this function that I created originally, it's being clever, but it's not efficient. So it's a very clever way to do it. So it's dynamic, but it's not efficient when you're dealing with tons and tons of vertices. So I'm better off just cutting out the if statements and get rid of the loops and just pure mathematics. That's all. Everything here is just pure addition, subtraction, division, whatever. Just pure mathematics. No programming logic in these 2 functions. So that's one thing I changed for the armature when it comes to skinning is that I'm getting rid of the logic and just keeping it as pure mathematics, just pure math, and that's it. And there's nothing else goes to it. And then you just pass in the information like you did in previous videos. Scaling is the only difference. And when we're doing the weighting, I do scale the weight, so the weight gets scaled correctly, and we just multiply our position by the scale, and then we apply our rotation and transform, which comes from our dual quaternions. So a lot of, like I said, a lot of this came from the knowledge of pure transforms. Like I said, that knowledge made it easier for me to implement scaling in this effect, because I know scaling happens first, then you just do rotation and position, and dual quaternions are just rotation and position applied together. Like here's the example up here. So, like I said, like I said in the previous video, even though if I don't use it all as the main way to, like I might just replace it back with model matrix, that knowledge is very good because you can use it for other things. Like I said, it made it super easy for me to do this. Since I already went through like I said, I was trying to actually get this to work with skinning. I couldn't get it to work with skinning, so I went back and just added dual quaternions, and everything worked beautifully. So I got all my rotation, my position, and my scaling working beautifully. And the file, like, there's not really much to it. This is how how I'm animating it. You know, I'm initializing our new two systems. A lot of this is the same thing as before. It was just armature. I think it was just new joint. Now it's just new bone. I save the entity, and the entity gets passed in as the parent. You finalize. Finalize does the bind pose for it. Preview, I kind of just add. So I have another component, or another entity to create a preview, and I added the armature component to it. And this is my geometry. This is the skinned object. Kind of has its own like custom draw function, because I haven't found a way to update the UBO globally yet. So I have to fix up the rendering system to handle UBO armature. But for now, I'm doing this. So this is kind of like a hack. I kind of mentioned that this is a kind of a hack section because it's not built into the rendering system yet. But at some point, if I see that this object exists or this component exists inside the entity, and then I'll just automatically update the UBO armature, and then just call it a day. Yeah, that's it. Everything else is like the same thing that I've been doing for so long for armatures. Like this has always been my test example. But like I said, it works really well. Everything's now an entity. Every bone is an entity. I can apply scripts to it. I can modify it. I can do whatever I want. So modifying a bone is modifying an entity. It's just using transforms and everything. So I can add physics and things like that. I don't think I have any samples of doing anything funny. No, not really. But let's see. Oh, that's right. I can try adding scale to the z-axis. See what happens. So you can see what scale looks like when I change. Whoa. And there you go. So now you can kind of have like I could build like a bone or a tentacle that stretches because I can just scale it in the y-axis. So that kind of gives, like I said, gives you a lot of finite controls over it. So if I were to say scale by 1, 1, and just scale it by y, all it does is stretch it out. So like I said, that developer, he said he really wanted finite control when it comes to scaling when you're dealing with skinning armatures, and I'm building it into it. So maybe you know, whatever 3JS framework that does armatures, maybe they can look at this example and implement it for 3JS if they wanted to, if they want to add scaling in 3 axes, or maybe they have a better approach to it. But here you go. So it's S, S, and 1. So this way it runs better. So yeah, I just like that. It's kind of cool that it just shrinks and then resizes. And the bottom is scaled, the middle is scaled differently, and the top is dynamically scaled. So you kind of get that nice hourglass shape. And let's see, that's been 30 minutes. All my videos have been coming to 30 minutes. So here you go. That's entities. The entity framework using, or the armature using the entity framework. So like I said, all the bones are now just entities. I better stop so soon before I have a power outage. Still lightning. So yeah, that's it. This is the starting of some really fun stuff. Like I'm continuing creating IK and an IK framework. So this we can do procedural animation. So we can. I'm kind of hoping we can do walk cycles, run cycles. If you get near a wall, your hand can reach out and touch the wall. If by using by proximity, like just really some really fun, crazy things. I really want to do a lot of fun things, and I want the animations to be so dynamic that I can add the rigs to any rig. So if I have like one animation set up, I can apply it to anything, and I want it to be parameterized as well. So this way we can do animation additives. So if I have like a character that has a walk cycle, maybe I can add extra animations to the animation, or I can have it swaying its hands a little bit, or shaking its head back and forth. But that's just adding on dynamically to the walk cycle that it's already created. So just all these little fun dynamic animations we can do. But to make, and like I also want to do physics. Let's say I want to have a tail, and if I rotate the body, I want the tail to act like it's following the body, and the end of the tail is kind of like lagging behind. But that requires a little bit of physics. So that's why the bones need to be created into entities, because this way when I start adding, because I have a motion component, so I can add a motion component, or I create a new type of like a bone motion component that allows me to apply motions and directions and velocity to the bones in a certain way, so it allows me to do fun things like have a tail sway back and forth based on movement, and that could lead to like hair moving, because I need hair, like if you're walking and you're bouncing, your hair can move and sway, your ponytail, certain bits of clothing can shake and move based on velocity. Of course, boob physics. that might be in the future, boob physics. That all ties into applying physics, motion, like just adding velocity and motion, and of course constraints. You need that's why we did some videos on constraints, because even if we apply a whole lot of velocity, we got to make sure that rotation doesn't go past this constraint. So all this has been building up little by little, chunk by chunk. We're building everything from scratch. So it takes a while, because there's a lot of little bits and pieces that need to be built to get to there. But we're getting there. So we're getting really close to start doing some, creating some IK walk cycles. That's what I'm hoping to do in the next couple of videos. So in the next couple of videos, I'm going to continue using this new framework, but I'm going to start doing IK chains and start trying to create some tentacles. So we can try to animate and control tentacles a little bit. So that'll be fun, and then start building a walk cycle and a bunch of other fun things too. So yeah, it's gonna be great. It's gonna be fun. So it's little by little, and we're gonna get there. So yeah, we're going full steam ahead from now till the end of my unemployment. I'm going to really focus on building an IK rig system as functional as possible, and see how I got like maybe 2 months left before I really need to get a job. So if you're hiring, I'm looking. If not, I'm going to be working for the next 2 months on this system, and make videos about it, so you guys get to learn. So yeah, let me just end it there. So again, please like and subscribe, and see you guys in the next video.